Hello friends, how are you? In yesterday class we discussed about modern periodic table and also discussed two periodic properties, which was atomic size or atomic radius, we can say that, and the second one was effective nuclear charge. Okay, now in today's class I am starting the third property, that is ionization enthalpy. That is ionization enthalpy or ionization potential. Okay, now firstly let me talk about its name. Its name is ionization. That means here ion formation takes place. This energy related with the ion formation, which is cation. Okay, enthalpy is used for the energy. That means simply we can say that this is the energy which is required to form a cation. Got it? Now let me discuss its definition. Then the amount of energy required, the amount of energy required to remove an electron, from outermost shell of gaseous isolated atom, is called ionization enthalpy or ionization potential. It is called ionization enthalpy or it is called ionization potential. It is measured in units which are calorie per mole, kilojoule per mole, or electron volt per mole. That is EV, electron volt per mole. These are the units of measurement of ionization enthalpy or ionization potential. Got it? Now there are different kind of ionization enthalpies, which are which is based on the how much electrons and which number of electron is removed. Okay, here that is the equation of general equation to showing that isolated atom or neutral atom, sometime it is used neutral atom also, isolated atom or neutral atom gas, the supplied energy, that is ionization enthalpy, and it results the removal of an electron, that is the removal of an electron which forms cation. Got it? Now there are various ionization enthalpies depending upon then which electron is removing. If that is only first electron is removing, that is called ionization enthalpy first. If second, that means one more is removing, then it is called ionization enthalpy second. And if it is third is removing, then it is called ionization enthalpy third. Removing first, that is ionization enthalpy first, second, that is ionization enthalpy second, like that. Suppose that is a neutral atom E. It is a neutral atom E, and we are removing one electron. So that is the first electron, so that is called IE first, ionization enthalpy first. Now if we are removing from this cation one more electron from this cation, then it is called ionization enthalpy second. And third, if we are removing this +2 ion one more electron, then it is called ionization enthalpy third. So that is removal of first electron, that is IE first, second, that is IE second, and third, that is IE third. Okay, so the energy required to remove first electron from neutral atom is called first ionization enthalpy, and the energy which is required to remove one more electron from cation is called ionization enthalpy second. And similarly, energy is required to remove third electron is called ionization enthalpy third. As we discussed, it is observed that ionization enthalpy increase in successive manner. That means compare with the IE first and IE second, then IE second is more. Similarly, if compare with the third, then IE third is more, and so on. Okay, now the question comes in our mind, why it is happening. Suppose That is a atom which has 5 proton, which has 5 proton in the nucleus, and there are 5 electrons in its outer shell. Now we removed first electron, we removed one electron. Now how much electrons are remaining? That are 4. Okay, but there is no change in protons. As a result, the nuclear force which is experienced by these electrons, the remaining electrons, will be more, that means, with simply word we can say that there is increase in effective nuclear charge after the removal of electron. Clear? That means now we need more energy, and now we removed one more, so there is now 3 electron, and if we want to remove one more electron, then we need more energy, because after removing the one more electron there are 4 electrons, but there is no change in proton, so the attraction force will be greater, and in that case it will be more. Got it? So we can say that it is because the removal of an electron increase the effective nuclear charge on remaining electrons, so more energy is required to remove more electrons. So more energy is required to remove more electrons. Got it? On moving in a period, now let me consider its periodicity, that which kind of changes appear when we travel, when we move in a period or in a group. On moving in a period, again I am clearing, in the last class we discussed, but again I am repeating. On moving in period, that means moving left to right, and on moving in a group, that means up to down. Okay, now we are moving in a period. When we move in a period, atomic size decreases and effective nuclear charge increases. Atomic size decreases and effective nuclear charge increases. It results decrease in size, so we need more energy. Therefore we need more energy. To understand it, let me take example of two atoms. One is the bigger one and one is smaller one. You should know that, I think you know that, the effective nuclear charge decrease with increase in distance. That means these electrons will felt less attraction force rather than these, because these are much closer to the nucleus. So we can say that it, the increase in atomic size decrease the effective nuclear charge, and if we reverse it, that is decrease in atomic size increase effective nuclear charge, and increase in atomic size decrease effective nuclear charge. Got it? Now in a period, there is increase in atomic size, there is decrease in atomic size and increase in effective nuclear charge. It results the these electrons will felt more attraction power, hence we required more energy. That means when the value of IE will be more. Got it? So we can say that in a period the value of IE increases. When we move in a group, the atomic size increases and effective nuclear charge decreases. Hence the outermost shell's electron will felt less attraction force, so we required less energy to remove them. That means the value of IE, ionization enthalpy, decreases in a group. Got it? Clear? Now after the discussing of ionization enthalpy, let me discuss one more, that is electron gain enthalpy. Electron gain enthalpy, delta EGH. Its symbol is delta EGH. Electron gain, HH is a symbol of enthalpy. So delta L, delta EGH. Okay. Sometimes it is also called electron affinity. But let me clear you, there is a difference between electron gain enthalpy and electron affinity. But up to the class 10th, 11th, 12th, we can consider both of them as synonyms. But there is a difference. But which difference is? Electron gain enthalpy is related with the gaseous isolated atom, but there is just a neutral atom, no matter of that is a solid, liquid, gas. Okay. Now, what is electron gain enthalpy? The amount of energy required, the amount of energy released, that is the amount of energy which is released when an electron is added in the outermost shell of gaseous isolated atom. The amount of energy released when we add one or more electrons, then some amount of energy is released. Okay, this amount of energy is known as electron gain enthalpy. Got it? For example, suppose that is a neutral atom and we supply the electron. It forms anion and free energy, release energy. This amount of free energy is known as electron gain enthalpy. Got it? Now, let me consider its periodicity. Which kind of changes appear in periodic table about the electron gain enthalpy? On moving up to down, when we move up to down in a group, that means up to down, atomic size increases and effective nuclear charge decreases. It results decrease in electron gain enthalpy. Now the question comes now, and why? As I am clear that more electron is more stable closer to the nucleus. Similarly, when it is far enough, then its energy is high and it is less stable. In group, effective nuclear charge decreases, so the electron will far away from nucleus. Hence, there is less energy is released. Got it? So we can say that in a group, delta EGH decreases. If we consider the period, that means on moving left to right in a period, atomic size decreases and effective nuclear charge increases. It results delta EGH is also increase. That means in a group, delta EGH decrease, while in a period, delta EGH increases. Okay. Now there is a two facts about the electron gain enthalpy. EGH can be positive or can be negative. Depending upon the nature, or we can say that electronic configuration of element. Got it? Now let me discuss something about it. Suppose you are an atom and stability that is 8 electron, because in class 9th we discussed that all the elements want stability, and the stability is related with the 8 electron in outermost shell. Okay. Now suppose you are an atom and for stability you need 8 electrons. Now one condition is that you have 6 electrons and I supplied to you two electrons. That means the receiving the electron make you stable, so you will release energy. But if you already have 8 electron, then if I give you 2 more electrons, then you will refuse because it is disturbing your stability. In that condition, I have to force you. I have to force you to receive the electron. That condition is negative value. That means we are supplying energy. And the first one, that was positive. That means releasing energy. Got it? The second fact is, in group sometimes it shows irregularity. That means ionization enthalpy shows irregularity because of the electronic configuration here. Okay. Now let me discuss the next topic, is that is valency. What is valency? The combining capacity. The combining capacity of an atom of element is called valency. The combining capacity, that means we can say that the number of bonds formed by an atom. So we can also define valency as the number of bonds formed by an atom of element is called its valency. Got it? The third one definition, it is different, little bit different. But starting before that, let me remind you something, that hydrogen makes single bond while oxygen makes double bond. Okay? If 3 hydrogens bonded, then they will form 3 single bonds. And if 4 hydrogen is added, then it's 4 single bonds. It forms 4 single bonds. That means its valency is 4. So we can say that valency is equal to the number of hydrogen atom attached. While when oxygen combined, then it will satisfy 2 valency of that element. Okay, so if we considering these points, then the definition becomes the number of hydrogen atoms. The number of hydrogen atoms combined with an atom of an element, or double of oxygen atoms combining with an atom, is also called valency. In my opinion, the first and second are much better than this. Now, valency is determined by valence electron of outermost shell, because an atom, how much bond formed and which kind of bond it will form, is depends on the electronic configuration of outermost shell. Got it? If an electron required if an atom required 2 electrons, then it formed 2 bonds. It formed 2 bonds. That means its valency is 2. Got it? So valence is determined by valence electrons of outermost shell. Now let me consider its periodicity. There is an example. Firstly discuss about the example, then we will discuss its theory. This is a period, and that is a group. That is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. The outermost shell electrons in lithium is 1, beryllium has 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7 and neon has 8 electrons. Now, for stability, lithium has two options. Either it receives 7 electron, or it can donate 1 electron, because if it is donate, then its configuration becomes equal to the helium, which is an stable structure. So lithium has tendency to lose 1 electron, and by losing the 1 electron, it forms single bond, 1 bond. So its valency is 1. Beryllium either take 6 or donate 2, so it donate 2 normally, so that's valency is 2. Boron, carbon, nitrogen, oxygen, fluorine, they form covalent bonds. They form normally covalent bonds in which they share electrons equal to their requirements. For example, carbon electron configuration is 4. Its configuration is 4. So it shares 4 electrons. So valency becomes 4. Got it? Now, by taking this example, it is clear that valency is increasing then decreasing. And in the novel gases, that is 18th group, they have fulfill octet. That means outermost shell have 8 electrons. So they are stable. So they do, normally they do not make bonds. That's why their valency becomes 0. So we can say that valency firstly increase, then decrease and becomes 0 at noble gases. That is 18th group elements. Now, if we consider a group, then they have same valence electron in outermost shell. For example, lithium configuration is 2,1, sodium configuration is 2,8,1, potassium configuration is 2,8,8,1. That means they have same valence electrons. They have same valence electrons. So their bonds will be same. That's why in a group the elements have similar valency. Got it? Now some facts about the valency. The first, how can we calculate the valency of an atom? If it is S block element, then its valency is equal to the group number. That means the elements of first group have one valency, while the second group has two valency, and so on. Okay. If it is P block element, then its valency is 18 minus group number. 18 minus group number. For example, oxygen is in 16th group. It is in 16th group. So 18 minus 16, that is 2. So the valency of oxygen is 2. Got it? The D and F block elements. The D and F block elements shows variable valency. They shows variable valency. Which one? The D and F block elements shows variable valency. That means they shows more than one valency. We will discuss after few minutes about that variable valency. The one more fact about the valency is the element combined with the oxygen. If element is combining with the oxygen, then its valency can be up to 7. 1 to 7. Got it? To consider that example, that point, let me discuss some about let me discuss few example to clear out our last point. Here it is HCl and it is Cl2O7. In this the valency of chlorine is 1 and the valency of oxygen is the valency of chlorine in that compound, that is 7. I said double then oxygen to 7 to the 14, but there are 2 chlorine atoms, so 14 divided by 2, that answer is 7. Got it? If we consider one more example, that is oxygen, by combining the oxygen the valency in 1 to 7, we can consider that one also. That is H2S. In that one the valency of sulfur is 2, but when it forms SO3, then its valency becomes 6. Got it? Understand? Now let's come to the topic, that is variable valency. The elements of D and F block and few P block also, but there are only few. So the elements of the D and F blocks, shows more than one valency. They shows more than one valency. It is called variable valency. That means showing more than one valency. That property is known as variable valency. Got it? For example, CuCl and CuCl2. Here the valency of copper is 1 and here that is valency of copper is 2. in FeCl3, because one thing, let me maybe in the one question that comes to my mind, that how can we know about it. Chlorine makes single bond, so two chlorine are combining, that means the valency of iron is 2. Here three chlorine atoms are attached, so valency is 3. Got it? So valency FeCl2, in which iron valency is 2, in FeCl3 its valency is 3. So it is also showing the variable valency. Similarly PCl3 and PCl5. In PCl3 the valency is 3, but in PCl5 that is valency is 5. It is p block element. Now sulfur, same behavior is shown by sulfur. In the case of H2S, its valency is 2, but when it combines with the oxygen and makes sulfur trioxide, then its valency becomes 6. It is also a p block element. Okay. Similarly HCl Cl2O7, in which chlorine has valency is 1, and in Cl2O7 its valency is 7. Got it? Because of the variable valency concept, in nowadays new term, that is oxidation state, is using. Oxidation state is using. Got it? Now what is oxidation state? The number of electrons or charge, the number of electrons or charge accepted by atom or present on atom of any element from atom of other element. That means when it combine with other element, then the charge created on that atom which is combining with other element is known as its oxidation state. I am repeating again, the number of electrons or charge occupied by atom of an element from atoms of another element is called its oxidation state. For example HCl. Here hydrogen generally have +1 charge. When they combine HCl, then 1 electron of hydrogen transferred to the chlorine. It results positive charge on hydrogen and negative charge on chlorine. So its valence oxidation state is +1 and its oxidation state is -1. Now accepting electron, that is also related with oxidation state. When an atom receive electron, then the negative charge create on it. This created negative charge is equal to, or we can say that it is its oxidation state. Here 1 electron is receiving, so -1 is created, so its oxidation state is -1. Similarly oxygen receive 2 electron and form O2 -2, that's its oxidation state. Got it? The one more definition we can discuss about it, the charge created on atom, the charge created on atom of element when the other elements are removed in the form of natural ions is called its oxidation state or oxidation number. Now suppose we have to find the oxidation number of sulfur. Okay, the compound is K2SO4. Now if we remove this potassium and oxygen, then the charge which is created on the sulfur is its oxidation state. Here you know that potassium is generally shows positive charge, not generally, it is surely shows positive charge. When 2 potassium is removed, then opposite charge created on sulfur. That means because of the removal of potassium there is -2 on sulfur. Now oxygen generally remove in the form of oxide ion, O -2. when I remove 4 oxygen, then oppositely 4 oxygen, that means 8 electrons, 8 charge negative. So when we remove the oxygen, then 8 positive charge will create. Now if we combine overall about it, then -2 plus 8, the answer is +6. So the oxidation state of sulfur is +6. Got it? About the next topic we will discuss in next class. Thank you.